Every iPhone, every cutting-edge AI chip, every modern supercomputer begins its journey inside a machine built by a company most people have never heard of. Hidden in a quiet Dutch town, ASML spent decades solving one of the hardest engineering problems in human history, creating machines so advanced that no nation has successfully replicated them. As the race for artificial intelligence accelerates, this little-known company has quietly become one of the most strategically important businesses on Earth. They are the gatekeepers, the sole custodians of a technology so crucial that it dictates the pace of innovation across the globe. But how did a single Dutch company come to dominate such a vital, complex industry? What does it actually take to build the machines that build our future? And why, in a world of cutthroat competition, has no one else managed to catch up? The story begins not with silicon, but with signals. In the 1850s, the telegraph cracked open the information age, transmitting thoughts faster than a horse could run. A century later, in 1947, Bell Labs birthed the transistor, a tiny switch that would power everything to come. Then, in the late 1950s, Jack Kilby and Robert Noyce independently invented the integrated circuit, a revolution that packed multiple transistors onto a single piece of material. This wasn't just an invention. It was the birth of an industry. In 1965, Gordon Moore laid down a prophecy, now known as Moore's Law, predicting that the number of transistors on a chip would double roughly every 2 years. It became the drumbeat for the entire semiconductor world, a relentless quest for smaller, faster, more powerful chips. The key to this shrinking act was photolithography, a photographic process that prints intricate patterns onto silicon. By the 1970s, it was already sophisticated, but the demands of Moore's Law pushed it to its absolute limits. Amidst this relentless race for miniaturization, in 1984, a small joint venture called ASML emerged from Philips and ASM International in Veldhoven, Netherlands. They were the underdog, a tiny challenger against the entrenched giants of Japan who dominated the lithography market. Their early machines were basic, their funding meager, their prospects uncertain. Many in the industry dismissed them, convinced they were too late to the game, too small to compete. But ASML had a different vision. They understood that the future of computing hinged on ever finer details, and traditional optical lithography was approaching a physical wall. The light used to print circuits was simply too broad to create the atomic scale features needed for the next generation of chips. This looming physical barrier created an existential threat to Moore's Law, and by extension, the entire digital economy. The world needed a new kind of light, a new kind of machine, to keep shrinking the transistor. In the late 1990s, ASML made a radical, almost reckless bet: extreme ultraviolet, or EUV lithography. This wasn't just an incremental improvement. It was a leap into the unknown, technology so challenging that many experts doubted it would ever work commercially. EUV light has a wavelength of just 13.5 nanometers, a fraction of what came before. This allows for impossibly fine details, but it comes with a terrifying downside. EUV light is absorbed by almost everything, including air and even conventional lenses. This meant the entire optical path within the machine had to operate in an ultra-high vacuum, and glass lenses were useless. Instead, ASML had to pioneer a system of ultra-precise mirrors. They partnered with Zeiss, a German optics powerhouse, to develop these mirrors, polished to atomic scale perfection. Even a single fingerprint would degrade their performance. Simultaneously, ASML acquired Cymer, a company specializing in light sources. Their task: create a laser-generated plasma light source, literally firing high-energy laser pulses at microscopic droplets of molten tin, creating a plasma hotter than the surface of the sun to generate that elusive EUV light. This was a project of unprecedented complexity, costing billions of dollars and consuming decades of research with no guarantee of success. The stakes grew higher when, in an unprecedented move, industry titans Intel, Samsung, and TSMC, usually fierce rivals, collectively invested billions into ASML in 2012. They couldn't afford for EUV to fail. Their own future depended on it. After years of doubt, billions of euros, and countless engineering breakthroughs, a startling reality emerged. ASML had pulled it off. In 2017, the first commercial EUV systems finally entered high-volume manufacturing. The impossible had been made real. But the twist wasn't just that they succeeded. It was that no one else had. Despite decades of intense competition and massive investments by other global players, ASML had achieved a near-total monopoly on this critical technology. Their machines, containing over 100,000 individual components assembled with painstaking precision, became the only way to manufacture the most advanced chips on Earth. Transporting a single machine requires dozens of shipping containers, cargo aircraft, and trucks. They don't just build equipment, they orchestrate a global symphony of engineering and logistics. The companies that design our phones, our servers, our AI models, Apple, NVIDIA, Google, all became utterly dependent on ASML. They don't make the chips themselves, but they make the machines that make the chips. The hidden monopoly was complete. Then came the AI boom. The demand for cutting-edge chips, the kind only ASML's EUV machines could create, exploded. GPUs, neural processing units, data center silicon, every advanced AI system, from NVIDIA's H100s to Apple's latest mobile processors, flowed through ASML's technology. TSMC, Samsung, Intel, they all lined up for the chance to buy these colossal multi-million-dollar systems. This wasn't just about economic competition anymore. It was about national power. Control over ASML's technology became a strategic asset. The Netherlands, ASML's home, found itself in an unexpected geopolitical spotlight. In 2023, coordinated with allies, the Dutch government began restricting shipments of certain advanced lithography systems to China. President Xi Jinping's push for semiconductor self-sufficiency collided directly with ASML's unique dominance. The machines, once mere tools of industry, were now instruments of statecraft. The silent company in Veldhoven was at the heart of a global tech war, its factories deciding not just the future of AI, but the balance of power between nations. Today, ASML remains the indispensable gatekeeper of advanced chip manufacturing. Its EUV systems continue to push the boundaries of what's possible, allowing chip makers to create ever more powerful and efficient semiconductors. While the world's tech giants battle for market share and AI supremacy, their fates are inextricably linked to this one company. ASML has continued to innovate, developing even more advanced high-NA EUV systems, ensuring its lead remains formidable. The export controls persist, creating tension but also highlighting the strategic importance of what ASML has built. China continues to invest heavily in its own domestic semiconductor capabilities, but the monumental engineering challenges of replicating ASML's decades of work mean its dominance holds firm for the foreseeable future. The hidden monopoly endures, quietly shaping the technological landscape of the 21st century. The story of ASML is a potent reminder that the most impactful revolutions often begin in the most unexpected places, driven by quiet persistence and an unwavering belief in long-term research. It reveals how profound engineering challenges, when overcome, can create bottlenecks of immense strategic value, making a single company the linchpin of an entire global economy. In an age where digital power is paramount, ASML teaches us that the future isn't just written by the innovators we celebrate on stage, but by the unsung heroes who build the very foundations upon which those innovations stand. Their story underscores the often invisible layers of complexity that underpin our technologically advanced world, and how decades of dedicated effort can culminate in an extraordinary, almost unassailable position of influence. What other hidden companies do you think hold disproportionate power in the tech world? Share your thoughts in the comments below, and consider subscribing for more stories about the unseen forces shaping our technological future.